This demo shows how a site analysis can be performed using the Spatial Analyst tools in Model Builder. Geographic problems often require the analysis of many different factors, which are often in different value scales. The weighted overlay process allows you to overlay several rasters into a common evaluation scale of suitability so they can be combined into a single result. Using the project data, you will locate suitable areas for a new school. The source datasets are elevation, rec sites, schools, and land use. The slope will be calculated from the elevation data and used as a criterion. The distance to recreation sites and distance to existing schools will be used to place restrictions based on proximity. The land use raster can be directly used since it is already within the correct scale. Geographic problems often require the analysis of many different factors, which may also be in different value scales. The weighted overlay process allows you to overlay several rasters into a common evaluation scale of suitability so they can be combined into a single result. The first part of the model will use the slope tool to find areas of relatively flat land from the elevation raster. The Euclidean straight-line distance is calculated for the rec sites dataset. The Euclidean distance tool is again used, this time to find locations away from existing schools. All of these rasters are continuous datasets. In order to combine them, they must be set to a common measurement scale. Since slope is a continuous phenomena, it must be categorized into classes of suitability. We classify the raster into 10 values between 1 and 10, with the more suitable attributes given the values closer to 10. The schools should be located as close as possible to a recreational facility. We classify the Euclidean distance values so that shorter distances are given a higher weight value, since they are more suitable or desirable. The new school should be as far away as possible from any existing ones. We classify the distance values to give greater distances a higher weight value, which is more preferred. All the more suitable cells now have higher values. Because you can weight the cell values as part of the overlay process, the land use dataset can be used in its original form. As mentioned previously, the weighted overlay tool overlays several rasters using a common measurement scale and weights them according to their importance. There are several evaluation scales that can be selected from, or you can enter start, end, and interval values of your choosing. In this example, the evaluation scale was set to go from 1 to 10 in increments of 1. A weighted overlay table was previously generated to facilitate the demonstration here. The first raster considered in the overlay table records the locations far from existing schools. This was considered an important factor and was set to 50% influence. The next most important raster identifies locations near the recreation sites. The influence of the recreation sites was decided to be 25%. The next raster is for the slope. The areas where the slope exceeds a certain threshold are considered too extreme and will be set to restricted. The influence of the slope here is set to 13%. Finally, we have the land use layer. Here we will use a particular field of the raster, land use. The appropriate scale values are selected from the raster. Areas that are completely unsuitable are set to restricted. With the table established, the output raster is named Suit Areas. The weighted overlay is run. The model will be saved and closed at this point. The green shades show the most desirable locations for putting the new school. The parameters can be easily changed and the model rerun. This allows you to quickly try other scenarios, giving you a very powerful tool with which to explore your data.